topic of this video is linear equations in one variable. When we solve linear equations in one variable, we need to keep in mind what the properties of equality allow us to do in that equation. One property is called the addition property of equality, and that means if we're adding the same number to each side of the equation, that will result in equivalent equations. So if we add a negative number to one side, we need to add a negative number to the other side. Adding a negative number, remember, is the same thing as subtraction. So the addition property really encompasses both adding or subtracting a number from both sides of the equation. Multiplication property means we're going to multiply both sides of the equation by exactly the same amount, and that will result in equivalent equations. Multiplying by a fraction is the same as dividing. So if you multiply by 1/2, that's the same as dividing each side by 2. So no matter if you're adding, subtracting, multiply, or dividing, whatever operation you are doing, make sure that you're doing exactly the same operation to both sides of the equation. Some of the equations we're working with today will either have fractions or decimals. Now decimals are pretty easy just to work with, especially if you're using your calculator, so we don't worry about them so much. But if you want to eliminate decimals, you can find some factor of 10 to multiply every term by, and then your decimals will be eliminated. Fractions are a little more complicated. In order to eliminate fractions from a given equation, you will have to find the lowest common denominator. So when we come across a problem like that today, I'll show you step by step how to determine what the lowest common denominator is and how to use it. Our solutions today will be one of 3 cases. So we're going to consider equations that have one solution. Those are called conditional, and the variable is equal to a number. Another case where there's no solution at all is called a contradiction, and we'll end up with some statement that is false, something like 2 equals 7. Well, we know 2 does not equal 7, so if we end up with something like that today, we just know that that means there is no solution to that equation. Finally, the case with infinite solutions. That's called an identity. And there are so many solutions that we could never list them all, so we call those all real numbers. You'll end up with some true statement like 2 equals 2. Well, we know that is true, so if we end up with something like that today, we'll know that there are an infinite number of solutions to our equation. So here's pretty much the procedure that we want to follow. The first thing we want to do in step 1 is to clear the equation of fractions by multiplying both sides of the equation by the lowest common denominator. That's if we have fractions. So once we clear the equation of decimals or work with decimals or clear the equation of fractions, then we're ready for step 2. If we have any parentheses, we want to make sure we use the distributive property to remove those parentheses or any grouping symbols in the equation. That will allow us then to combine like terms. Step 3, we will use the addition property of equality to help us collect like terms on each side of the equation. So basically, we want a variable to be set equal to some number to solve the equation. And finally, we may also need to use the multiplication property of equality to isolate that variable. And it always is a good idea to check your answer. Basically, that just means if I get x equals 1, I want to substitute 1 back into the original equation to see if it really works or not. So to the left, I have all the steps written out again just to remind us of what order we should be proceeding in. So here's our first example, just scanning I don't see any decimals. I don't see any fractions, but I do see grouping symbols. 6 minus 5c is inside. 6 is a constant term, which means it is always the value of 6. But 5c is a variable term, because depending on what we let c equal, that term can take on an infinite number of values. So I cannot combine 6 with negative 5c. So the best thing I can do to eliminate these parentheses is to distribute this term, negative 3, that is outside of the parenthesis. So negative 3 is distributed to each term inside that quantity. So 9c remains. Negative 3 times 6 is negative 18. Negative 3 times negative 5c would be positive 15c. And right there is where a lot of mistakes occur. Negative times negative becomes positive. Equal sign is next. On the right side of our equation, again, we have parentheses. 3c is a variable, 9 is a constant. So they're already simplified as much as can be. So we're distributing negative 2 to each of those terms. C minus 6c, negative 2 times 9 would be minus 18. So now we've simplified by eliminating the parentheses, but notice that you have some like terms. We have two terms with a variable, so we need to combine 9 plus 15 to get 24c minus 18. And on the right-hand side, c minus 6c are like terms. So this c really is 1c minus 6c. That's negative 5c minus 18. Notice that we have the variable c on both sides of the equation, and we have constant terms on both sides of the equation. So our work is not done. We need to collect all the variables on just one side alone. So I think I will use the addition property and add 5c to both sides of the equation. Notice what happens. It eliminates from one side and collects on the other. So I have 29c minus 18 is equal to negative 18. Now, since I've already collected the variables on the left side, I want to collect all the constant terms on the opposite side. So this negative 18, I will add 18 to both sides. This is our addition property, so that I can eliminate it from one side and collect it on the other. That leaves 29c equals, notice how these terms are opposites, so that leaves me 0. So we're not quite done. In order to isolate our variable c, think about how c is connected to 29. 29c means 29 is multiplied by c. So the opposite of multiplying would be dividing by 29. So both sides of the equation are divided by the same amount, 29. Reducing, I'm left with c equals something. When you have 0 in the numerator, 0 divided by a number will be 0. Try that out on your calculator. It will give you 0. If 0 is located in the denominator, then we would have something undefined, and your calculator would say error. But in this case, 0 in the numerator does equal 0, so our answer is 0. We could substitute 0 back into the equation to check the answer and see if it really works. So I'll do a little check. 9 times 0 minus 3 times the quantity of 6 minus 5 times 0. Does that really equal 0 minus 2 times 3 times 0 plus 9? So 9 times 0 is eliminated. 5 times 0 is also 0, so we're going to have 6 take away nothing inside of those parentheses. So negative 3 times 6 is on the left-hand side. 0, that's eliminated. 3 times 0 would be 0. So we're left with negative 2 times 9 on the right-hand side. So our final evaluation here, negative 3 times 6 would be negative 18 on the left. Negative 2 times 9 is also negative 18. And you can see that substituting 0 really works. We are left with a true statement when we substitute 0 back into the original equation. In example 2, you can see that we do have a decimal. We have parentheses as grouping symbols. So our first step is to eliminate the parentheses by distributing. 0.4 times n would leave us 0.4n. 0.4 times 3 would be positive 1.2. On the right-hand side, we're distributing 0.2 to each term in the parenthesis. 0.2 times 6 is 1.2, and 0.2 times positive 2n would be positive 0.4n. So it doesn't matter which side you want to collect your variable on. I like to collect the variable on the left-hand side, so it looks like I'll be subtracting 0.4n from each side. And notice what happens. N eliminates from both sides of the equation, leaving the constant 1.2 equals 1.2. Well, that's true. Those numbers do equal each other. So this is a case of an identity. So when we have an identity, it means all real numbers are the solution. So any real number you want to substitute for n is going to work. We could substitute a 3 or a negative 8/3. Anything you want as long as it's a real number. Even the square root of 7 would work. So this is one of our special cases. Keep this one in mind. In our third example, we have parentheses again. So we're going to distribute to simplify. We have 10x minus 2x minus 8 on the left. On the right-hand side, we'll distribute 8. So 8 times x would leave us 8x. 8 times negative 2 is minus 16. And finally, plus 6 is not part of the distributing because it is not in the parenthesis. So be careful there. Now we're back to collecting like terms on each side of the equation. I can see that 10x minus 2x are like terms. 10 minus 2, that leaves me 8x minus 8 on the left. And I have some constant terms on the right that are like terms. 8x is by itself. Negative 16 plus 6 would give me negative 10. So I notice I have a variable on both sides. I have a constant on both sides. We're not done. Choose sides. So I'm going to collect all my variables on the left. So if 8x is positive right now, I need to subtract to move it. So I'm using the subtraction property of equality. Eliminate and collect. Well, 8 minus 8, that's eliminating actually on both sides. So I'm left with negative 8 equals negative 10. Well, that is not true. These numbers do not equal each other. When you have a false statement, you will not get a solution. So no solution. And sometimes we use the symbol for no solution. So please don't use this symbol for the number 0. It has another purpose. It's the empty set solution symbol. So only use this to represent no solution. In example 4, we have some fractions. So in order to solve an equation that has fractions, we need to eliminate the fractions. So I'm going to take each one of these denominators to help me determine what the lowest common denominator is. Starting with the number 4, I know that I can divide that by the prime number 2 and be left with 2. I can divide again by 2 and be left with 1. So all the prime numbers that 4 is divisible by are lined up very nicely here on the outside. So I have 2 times 2, which you could call 2 squared in exponent form. Next, we've got a 7. 7 is divided by 7, leaving me 1. So the only prime factor of 7 is 7. Finally, we have 14. Dividing 14 by a prime number, I could start with 2. 14 divided by 2 leaves me 7. 7 divided by 7 leaves me 1. So 2 times 7 are the factors of 14, the prime factors. So to build my lowest common denominator, that is the product of each unique factor to its highest power. So what I have to choose from is 2 squared, 7, and 2 times 7. So it looks like I have 2's and I have 7's. So I have 2's and 7's. Now I want to go back and make sure I have the highest power accounted for. For our first denominator of 4, I had 2 squared. That is a higher power than 2 to the first. So I need to account for the higher power. Next, I've got 7. So I've got 7 to the power of 1 and 7 to the power of 1. Both of those are 7 to the power of 1. Don't combine them. They are from different denominators. So the best we can do is have 7 power of 1. So however much 2 squared times 7 is, that's our lowest common denominator. So that would be 4 times 7, or 28. So the way we're going to use 28 is multiply every term by 28. So I'm going to have 28 times n minus 3 over 4 plus 28 times n plus 5 over 7 equal to 28 times our last fraction, 5 over 14. So what's going to happen here? 28 is not just floating anywhere. 28 is an integer. It's 28 over 1. So maybe that will help us to do some tracking better. So 28 can reduce with 4 in that first fraction. 28 fourths is exactly 7. Our next fraction, 28 reduces with 7, gives us exactly 4. And 28 reduces with 14 and gives us 2. So we don't have fractions anymore. That's why it's so nice to figure out the lowest common denominator and then multiply all the terms, because then the fraction will be eliminated. So I'm actually distributing 7 now to each of the terms in this first parenthesis set. 7n minus 21 is what I get. Next, I've got positive 4 to distribute into the second parenthesis. So positive 4n and positive 20. Last, positive 2 is multiplied by 5 to give us 10. So now it's more clear to see that we do not have any fractions remaining, but we do have a lot of terms here, so we need to collect our like terms. 7n and 4n are like terms, and then we have negative 21 and 20 are like terms. So 7 plus 4 would give us 11n. Negative 21 and positive 20 would give us minus 1. And that is all equal to 10. Notice that we only have one term that's a variable. So we're going to leave 11n right where it is, and we'll move this negative 1 by adding 1 to each side of our equation. That's our addition property of equality. So we eliminate it from one side and collect it on the other. We're left with 11n equals 11. And our final step, to get n isolated, notice n is being multiplied by 11, so the opposite would be divided by 11. Both sides of the equation are divided by 11. So now n equals 1. We actually have a solution, and when you do have a solution, it is called conditional. There is a solution, and that condition is that we let n equal 1, and that will solve the equation. So we've got one more example to work. In our last example, we have fractions again, but it looks a little bit different. So in order to know which terms really have fractions, I always suggest that you distribute before you try to eliminate the fractions, that you don't end up multiplying too many times by the LCD. So by distributing first, we'd have 1/3 multiplied by 8. So that's 8/3. 1/3 times 2c would be positive 2c over 3. So you can see how both of those terms actually have a denominator of 3. Now distributing 1/5, we would have 3c over 5, and 1/5 times negative 5 would be minus 5/5. I don't want to reduce 5/5 right now. I'm distributing on purpose so I can see what the terms look like as fractions to come up with our lowest common denominator. So one denominator is 3, the other denominators are 5, and if I try to divide these, well, they're only divisible by themselves. So they already are prime numbers, and they're different from each other. So 3 times 5 means 15 is our lowest common denominator. So I'm going to take 15 and multiply that by each term in our equation. So notice that 15 really could be written as 15 over 1, and it's fine to write that out if it helps you to track this better. And so we really can do some reducing here to eliminate our fractions. 15/3 really is 5. 15/3 again is 5. 15/5 is 3. And again, 15/5. It is really negative 15/5, which gives us negative 3. So you might find it helpful to include the negative with the 3 so you don't forget to use the negative. And that is a very common mistake. So what we have remaining is 5 times 8, which is 40. Positive 5 times 2c is positive 10c on the left. On the right, 3 times 3c would be 9c. And negative 3 times 15 gives us negative 15. So again, we're back to collecting variables on one side and constants on the other. So I'll subtract 9c from each side. And that leaves me 40 plus c equals negative 15. and subtraction of 40 will finish our problem. So I'm left with C equals, now the sum of two negative numbers is going to be a negative 55. So our answer, C equals negative 55. Since we do have an answer, it's conditional.